Alright, good evening everyone. Tonight I'll be going through the 2011 paper 1 for GCE O-level additional mathematics. So same drill as for the previous papers. I'm just going to be going through all the questions, and if you have any questions you can leave them in the comments. Alright, now I got a new microphone and it is a wireless one, so it allows me to just walk around more freely, but I am not too sure about the quality of the mic. So if there's any feedback from heavy bass, then I do apologize in advance. But anyway, let's just get started with the paper. So you can see here, the first question is that given that y is equal to e to the x power over x for x is greater than 0, find the range of values of x for which y is a decreasing function. Okay? 1 second. Okay. So, so we know that y is equal to e to the x power over x, where x is greater than 0. So we need to find the range of values for this as a decreasing function. So that's quite simple. Just do dy dx. Okay. So, simple thing. We have x, right? Then du dx is just e to the x. Derivative of e to the x is itself. Minus to the times e to the x. And then 1, right? And then this is all over x squared. Okay? And then what does this simplify to? Well, this is quite simple, right? This is e to the x minus 1 all over x squared. Okay? So we want this to be less than 0. Okay? So if this is less than 0, let me just write that. If dy dx is less than 0, this will definitely be positive, which means that the only way this can be negative is if x minus 1 is less than 0, right? Okay? So we must have x must be less than 1, correct? And then this will be negative. Okay? However, we are also given in the conditions that x must be more than 0. So therefore, we must put the 0 here. So that's quite simple, right? Yeah. Question 2. The diagram shows part of a straight line graph drawn to represent the equation y equals to a over x plus b, where a and b are constants. Given that the line passes through 2, 6 and has greater than -3, find the value of a and of b. So we can see on this graph that xy is being plotted against y, meaning that we start off with this equation, xy equals to my plus c. We need to find m and c. Actually, m is given to us, right? And we have to get the goal of y equals to a over x plus b, and then find the values of a and b, right? So let's see. So we know that m is equal to -3, right? So let's use our points. We have 6 is equal to -3 times 2 plus c, and c is equal to -12, right? So that means that we will have, oh sorry, this is 12. So we have c is equal to 12. So that means that we have xy equals to -3y plus 12, right? Okay, so now we want to get ourselves into this form. So why don't we factorize the y? So if I add 3y to both sides, then I have xy plus 3y equals to 12. Then y times of x plus 3 is equal to 12, then y is equal to 12 over x plus 3. And this is exactly the form that we wanted. So a is equal to 12 and b is equal to 3. Alright? So this is normal linear law. It's pretty easy. Question 3. Without using a calculator, find the value of 6 to the power of x, given that 3 to the power of x plus 2 is equal to 12 to the power of 2 minus x. So we have this, we want 6 to the power of x. Okay? So first thing we want to do is see if I can get this in terms with 3, right? So that we kind of have common terms, and then we'll see what we can do from there. So 12 is equal to 4 times 3, right? And 4 is 2 squared, meaning that this right side is equal to 2 to the power of 4 minus 2x times 3 to the power of 2 minus x, isn't it? Okay? So we want to work our way to 6 to the power of x. So we will do that. First, we will get rid of this 2, and then we will multiply by 2 to the power of x, right? So 3 to the power of x is therefore equal to, the left side will stay the same, 2 to the fourth minus 2x times, and then this is what gets affected here. We'll have 3 just to the negative x, right? Because we cancel out the 2 on both sides. Then I will introduce a 2 to the power of x on both sides. 3 to the power of x times 2 to the power of x is, this is what gets affected. So we have 2 to the power of 4 minus x times, this remains the same, 3 to the power of negative x. Okay? So now we can do 6 to the power of x. Okay, let's see. 2 to the power of 4 is 16, but there's a minus x here, so this is actually going to go to the bottom with 2 to the power of x. 3 to the negative x is also going to go on the bottom, so actually the bottom also has a 6 to the power of x, and the top is 16. So, typical thing, we will multiply both sides by 6 to the power of x. 6 to the power of 2x is thus 16, and of course you can square root both sides. Okay, 6 to the power of x is equal to plus minus 4. But wait, this is power, right? Meaning that cannot be negative, right? So 6 to the power of x must just be equal to positive 4. Okay? Question 4. Solve the equation 2 cosine 2 theta is equal to 4 plus 5 cosine theta for 0 is less than or equal to theta is less than or equal to 2 pi, giving your answers in radians correct to 2 decimal places. Okay? So, let's see. Now, there's a problem. We have the 2 theta, right? We want to just get this to a single theta. But there are 3 different formulas for this, right? Which do we choose? Well, we have this cosine, right? So we want everything to be cosine. So let's use 2 cosine squared theta minus 1. Okay? So let's change this to 2 times of 2 cosine squared theta. So 4 cosine squared theta minus 2 is equal to 4 plus 5 cosine theta. Right? And then of course, this just becomes a quadratic equation. 4 cosine squared theta minus 5 cosine theta minus 6 is equal to 0. Okay? And then, okay, this was 4 cosine theta plus 3 and cosine theta minus 2 is equal to 0, right? Yeah, okay, so that means that cosine theta is equal to negative 3/4 or cosine theta is equal to 2, okay? But this has no solution, right? Okay, so we will just take this. So now we want the basic angle. Alpha will be the inverse cosine of the positive version, which is, okay, 0.72273. Okay, I'll put this in 5SF. Okay, so, but this is negative, which means that we have it in the second or third quadrant, right? So we have theta will be equal to pi minus alpha, or theta will be equal to pi plus alpha. And if you work it out, this means that theta is equal to 2.42, or theta equals to 3.86. Okay, so these are radians, okay? These are radians, and the question said 2dp, but anyway these are also 3SF. Okay, so yeah, I did not work this out obviously, but if you press the calculator you'll know that this is this, and then of course I wrote down the answers already, so I know what this is and what that is. Okay? Question 5. The variables x and y increase in such a way such that when x is equal to 2, the rate of increase of x with respect to time is twice the rate of increase of y with respect to time. Given that y is equal to k times square root of 4x plus 1, where k is a constant, find the value of k. So we have this, so we need to find dy dx. I'll share with you a little bit of a shortcut when it comes to square roots. So by the chain rule, you know this is half, and then when you bring this down, it becomes negative half, which means that whenever you see a square root, when you take the derivative, the square root will just come to the bottom. So pretty big shortcut for you guys, okay? And then we have the half that we bring down, and the derivative of this, which is 4, so that becomes 2. So this is just 2k on the top, right? Okay? So we know that when x is equal to 2, okay, so first we'll write down what is dy dx. dy dx will be, this is 9, right? So this will be 2/3 of k, right? And then we also know that this is equal to, we know that dx dt is equal to 2 times of dy dt, which is equal to 2 times of dy dx times dx dt, right? Which means that 2 times of dy dx is equal to 1, right? So we'll take this. So we know that 4/3 k is equal to 1. That just means that k is 3/4. Okay? Yeah, that should be pretty simple. Question 6. A solid rectangular block has a square base of side xcm and a height of ycm. The total surface area of the rectangular block is 120 square centimeters and the total length of the 12 edges is 54 centimeters. Show that x squared minus 9x plus 20 is equal to 0 and find the possible values of x and of y. Okay, so we will first have to set up some equations, right? So we know that the thing has a square base, side xcm, and a height ycm. So surface area, we got the two square parts, 2x squared, plus the four sides with side x, height y, 4xy, total 120. Then, second equation, the total length of the 12 edges. We know that there are going to be 8x's and 4y's, right? So 8x plus 4y is equal to 54. And of course, this means that we just need to substitute, right? Now, I don't actually need to simplify anything here because there's literally a 4y right here. So I can just write 4y as 54 minus 8x and just substitute this directly into here. And yeah, so 2x squared plus x times of 54 minus 8x will be equal to 120, right? So let's see. We have the minus 6x squared. So minus 6x squared, okay? And then this is 54x. So plus 54x minus 120 is equal to 0. And then of course we will simplify this by dividing everything by -6. So x squared minus 9x plus 20 is equal to 0, shown. The question wanted us to show this little thing. Okay, so now we will solve for this, right? So x minus 4, x minus 5 is equal to 0, x is equal to 4, or x is equal to 5. And both of these are valid. We'll just substitute these back into here to find out our y, right? So we have 54 minus 32, which is 22. So y is equal to, should be equal to 11 over 2. Or, in this case, where x is equal to 5, y will be equal to 14 divided by 4, which is 7 over 2. Okay? And yeah, these are corresponding values of x and y. Question 7 is binomial theorem. the coefficient of x in the expansion of 2 minus 3x times 1 plus ax to the 6th power is equal to 3. Okay? So find the value of the constant a. Okay? So we have this, right? So let's do this. Now, because of the second part, I'm going to be expanding this with the first three terms, okay? So the first term will just be 1, right? In this case, because whenever you have 1 plus something else, the first term is always 1, okay? 6 choose 1 is just 6. So this is 6, this is still 1, this is ax, plus 6 choose 2, and then this is still 1, and then 6 choose 2 is 15. So you have 15, a squared, x squared, and so on so forth, but we're going to stop here. To find the coefficient of x, we must consider this and this, this and this, right? So we'll have 6a, or maybe I'll write 2 first. So 2 times 6a minus 3 times 1 is equal to 3, right? Okay, so this is negative 3, so 2 times 6a is equal to 6. Okay, 6a is equal to 3, a is equal to half. Alright, that's easy, right? The second part is just using the value of a, find the coefficient of x squared in the expansion of, the same thing, right? Okay? So part 2, we need to find the coefficient of x squared. To find the coefficient of x squared, we need to consider this and this, this and this, right? Okay? So we will have 2 times 15 over 4, right? Okay? And then we have this and this, so minus 3 times 3, and this is 30 over 4 minus 9, which is 36 over 4, so this is negative 3 over 2. Okay? Yeah, this is a binomial theorem in 2011 was quite simple. Huh? There are other years where it was harder. Question 8 is modulus. If you are watching this video in 2021 onwards, you will not have this question, but I thought I would still go through it anyway. The diagram shows part of the graph of y equals to 3 minus modulus 2x plus 1. So find the coordinates of the points A, B, and C. Alright, so you can see that I've drawn the sketch here. Okay, so B is easy to find, right? We know that B is equal to, so we know that the y coordinate is 3, but what is the x? So this is when this is equal to 0, right? So we have this as negative half. Okay, so B is easy to find. But then we need to find the value when y is equal to 0. Okay, so when this is equal to 0, that means that this is equal to 3 or it's equal to negative 3, right? So 2x plus 1 is equal to plus minus of 3. Okay, so x is equal to 1 or x is equal to this will become negative 4, right? So yeah, negative 2, right? And then that means that a is equal to negative 2, 0, and c is equal to 1, 0. Okay? Yeah. Part 2, solve the equation 3 minus the modulus of 2x plus 1 is equal to x. So we have this, alright? So I'm going to bring the 3 to this side, and then this is going to be negative, so we're just going to flip everything. So 2x plus 1 will either be equal to 3 minus x, or 2x plus 1 will be equal to x minus 3. Okay, so then we just do the typical things. 3x minus 2 is equal to 0, or x plus 4 is equal to 0, then x is equal to 2/3, or x is equal to negative 4. Okay, and both of these are valid solutions if you go ahead and do your check. Alright? Question 9. The equation of the curve is y is equal to ax cubed plus b, where a and b are constants. The equation of the normal to the curve at the point where x equals to 1 is 5y plus 2x equals to 12. Find the value of a and of b. Okay, so we've got two equations, so I set them up as y1 and y2. Okay, so we have the equation of the normal. So if we can find the gradient of the normal, then we can find the gradient of the tangent at that point, right? So let's see. Let's start by changing this to the standard form, y equals to mx plus c. y2 is equal to, so bring that over and divide everything by 5. Negative 2 over 5x plus 12 over 5, right? Okay. And at the same time, let's just find dy dx. dy dx is simply 3ax squared, right? So let's do this. When x equals to 1, y2 is equal to, this is just 12 over 5 minus 2 over 5, right? So this is just 2, and dy dx is equal to 3a. Okay? So, based on y2, we know that 3a will be equal to the negative reciprocal of this, which is 5 over 2, right? Therefore, a is equal to 5 over 6. Simple? And then what about b? b will be equal to, when x is equal to 1, then we'll have this at the top. y1 is also equal to 2, so b will just be equal to 7 over 6. Okay? Yeah, very simple. Question 10. The diagram shows a rectangle ABCD in which AB is equal to 2 square root 2 plus square root 3 cm. Given that the area of the rectangle is 9 plus square root of 6 square centimeters, find without using a calculator the exact value of the C in the form of square root of A minus the square root of B, where A and B are integers. Okay? So we have the area and we have one side, so we can find the other side, right? So we'll have 9 plus square root 6, right? 9 plus the square root of 6 over the 2 over square root 2 plus square root 3. Okay? So we need to work this out. So let's see. So obviously the first thing we will do is rationalize this, right? So if we take the conjugate cert, then what's the bottom? 2 square root 2 squared is 8. Square root 3 squared is just 3. So the bottom will be 5. So we will have 5 on the bottom. We have 9 plus square root 6 times 2 square root 2 minus square root 3, right? So let's see what this is. We have 18 of square root 2 minus 9 square root 3 plus 2 square root 2 square root 6. Square root 6 is square root 3 times square root of 2. So the square root of 2 will join this, and then it will just be 2. So this is 4 square root 3. And then times this. So minus. So once again, there will be square root 3. So this will join to become a 3. And then you'll have 3 times the square root of 2, okay? And this is all over 5. And of course, this is just, if I just do this, I'll have 18 minus 3, 15. So this will become 3 square root 2 and then minus the square root of 3. Oops. But the problem is that the question wants it in the form of 2 surds only. So we have to convert this to a surd, even though that would not be, technically that would not be simplified. But it's what the question requires. So 3 square root 2 is the same thing as the square root of 18 minus the square root of 3. This is what the question requires, even though technically it is not simplified. Okay? And then we need to find the exact value of AC squared in the form of C minus square root D, where C and D are integers. Okay? So AC squared by Pythagoras theorem is this thing squared plus this thing squared, right? So we have 2 square root 2 plus square root 3 whole thing squared plus 3 square root 2 minus square root 3 squared. And let's work this out. So we need to expand each term separately. That's going to be a lot of terms, but never mind. We will have 2 square root 2 squared, which is 8 plus 4 times of square root 6, right? Okay. And plus 3. Then we have this. Then we have a squared, which is just 18, right? Minus the 2ab. So this is 6 square root 6. And then plus the 3. Okay? And this is equal to, so this is 11, this is 14, this is 32. 32, okay? Then minus this, so minus 2 times the square root of 6. Once again, the question requires it in the form of a single cert, even though that's technically not simplified. So this is 32 minus the square root of 24 square centimeters. I honestly find it really annoying that that I can't put it in the simplest form. Okay? Question 11. The diagram shows a rhombus ABCD in which the coordinates of the points A and C are -2 and 2 and 10 and 8 respectively. Given that the point B lies on the y-axis, find the coordinates of B and of D. Okay, so here's our diagram. Okay, so it's a rhombus, which means we know that the diagonals are perpendicular bisectors to each other, and the point where they intersect will be the midpoints of both of those lines. So let's first find the midpoint. The midpoint for both of the lines, by the way, will be, so we just take 10 minus 2 over 2 and 8 plus 2 over 2, and this is 4 and 5, right? So this is the midpoint. So you can imagine it's here. This is 4 and 5. Okay? Then the gradient of AC is equal to, use the gradient formula, y2 minus y1, x2 minus x1. So we have 8 plus, 8 minus 2 over 10 plus 2, right? Okay, this is 6, this is 12, so half. Gradient of the line BD will therefore be negative reciprocal, so this is -2. Okay, we have ourselves a point that we can use, so 5 will be equal to -2 times of 4 plus C, and C is equal to 13, right? Okay, and therefore the equation of BD is y equals to -2x plus 13 and B is equal to 0, 13, right? Okay, so we have that, but I'm running out of space. So what I'm gonna do is I'm just gonna erase this, but we're gonna take note of this and this. Okay? Okay? So now we're gonna find D, but we don't know the coordinates at all. So So let D be equal to, let's say, HK. Okay? So we know that B is 0, 13. So one thing we need to note is that the x-coordinates, the difference in x-coordinates and y-coordinates can help us, okay? So the difference in x-coordinates for B and A will be the same as those for C and D. Similarly, the difference of y-coordinates for these will be the same as well, okay? So that means that I can set up equations like this. These, okay? So let's say I have 0 plus 2, right? Comparing these x-coordinates will be equal to 10 minus h, right? And we also have 13 minus 2 being equal to 8 minus k. We are comparing the differences and we know that they will be the same because it's a rhombus, right? So from here, h is equal to this 2, so this is 8, and k is equal to this 11, so this is negative 3. And therefore, d is equal to 8 and negative 3. Okay? Part 2 is just to find the area of the rhombus. Okay? That's very easy. So here's the thing. Because it is a rhombus, I know that triangle ABC is equal to triangle ADC in terms of area, which means that twice the area of ABC will be the area of the rhombus. So I only need to consider points A, B, and C, for example. We know that B is equal to 0 and 13. So I'll just use my formula. But instead of using the rhombus, I will actually not put a half outside at all and just calculate the area of this triangle. And then if I don't put the half outside, it should give me the area of the rhombus, right? So we'll start with B since there's 0 here. Okay, 13, go anti-clockwise, minus 2, 2, 10, 8, and 0, 13 again. Alright, so let's see what this is. So we have 0. So this is, we'll start here. So minus 16. And then plus 130, then minus this, 13 minus 2, so this is plus 26, and then minus 20, right? So let's see. So this is minus 16 plus 130, so 114, 26, 140, 120. 100, okay, maybe I should move this over here so it's less confusing. Okay, 120 square units. Okay, that's it. Okay. Question 12. A particle P leaves a fixed point O and moves in a straight line such that t seconds after leaving O, its displacement s meters from O is given by s is equal to t ln t plus 1 minus t. So find when t is equal to 20, the displacement of P from O. Okay, that's actually, I don't even know why they're asking that, right? When t equals to 20, s is equal to 20 ln okay, 21 minus 20. I'll actually write this as ln 21 minus 1 just to make that cleaner. Okay, yeah, that's literally it. I don't really see, I don't really know why they asked that. Part 2, find the velocity of P. Okay, t is still going to be equal to 20 in this case. Okay, so let's do it. V will be equal to the derivative of s ds dt. Okay, so there's a bit of a product rule going on here. So we have t, and then the derivative of this, which is just 1 over t plus 1. Okay, then we have plus ln of t plus 1 times 1, right? And then don't forget the minus t, so this is minus 1. Okay, so let's see. So this is going to be t over t plus 1, but there's a 1 here, so minus 1. So let's make this t plus 1 over t plus 1. Okay, then this will just become minus 1 at the top. So I will have ln of t plus 1 minus 1 over t plus 1. So when v is equal to, when t is equal to 20, V will be equal to ln 21 minus 1 over 21 meters per second. Okay? So that should be fair enough. For the last part, we need to find the acceleration of p. Same thing, t is still equal to 20. So let's just find a, which is the derivative of velocity, dv dt. Right, this is equal to this ln here. It will just become 1 over t plus 1. Okay, this is minus of t plus 1 to the negative 1 power. So the bottom will become squared, and then this will just become positive. And yeah, and the derivative is 1, so we don't need to worry about that. So this will just be 1 over t plus 1 squared. And of course, I'll multiply the top and bottom here by t plus 1, so I can bring them together. So this is t plus 2 over t plus 1 squared, right? So when t is equal to 20, a is literally just equal to 22 over 21 squared, which is 441, yeah, meters per second squared. And that's it. Okay, question 13. Finally, we have reached the last question, which is our formula. The diagram shows a rod OA which is hinged at O and a rod AB which is hinged at A. The rods can move in the xy plane with origin O, where the x and y axes are horizontal and vertical respectively. The rod OA can turn about O and is inclined at an angle theta to the y-axis, where 0 degrees is less than or equal to theta, which is less than or equal to 90 degrees. The rod AB can turn about A in such a way that its inclination to the horizontal is also theta. The lengths of OA and AB are 5 meters and 3 meters respectively. Given that b is h meters from the x-axis, find the values of the integers a and b for which h is equal to a cosine theta plus b sine theta. Okay, so that was a really long-winded description, but the core is to find an expression for h. Okay, so this should be quite simple. This is the diagram that was given. So let's consider. So let's consider this side. Okay, so I'll consider here, and then I'll also consider here. Okay, so if this is theta, then this is the hypotenuse. Okay, so what is this side? Well, we don't know, but this is theta, which means that from this point, we are looking at it as what? This is an adjacent, right? So this will be cosine. So it is 5 cosine theta for this, and then we need to consider this one. This is 3 meters, and this is theta. This is the hypotenuse. This here is the opposite. So this will be sine. So this is simply h is equal to 5 cosine theta plus 3 sine theta. That was very simple, right? Okay. We won't need the diagram for the rest of the question. So let's just take note of the expression of h. Part 2, using the values of a and b found in part 1, express h in the form r sine theta plus alpha, where r is greater than 0 and 0 degrees is less than or equal to alpha, which is less than or equal to 90 degrees. So this is just expressing it into the R formula form, right? Okay, so sine of theta plus alpha, so that means that we'll have this, okay? So let's let this be equal to r times of sine theta cosine alpha plus sine alpha cosine theta, right? Okay, so let's see. R cosine alpha is equal to 3. R sine alpha is equal to 5, right? So if we square both of these and put them together, we will get the r squared, and then we will get r is equal to the square root of 3 squared plus 5 squared, which is equal to just the square root of 34. Okay, and then alpha will be equal to the basic angle, right? So we'll take the sine inverse of 5 over the square root of 34, right? Yep. Okay, this is 59.036 degrees. to 3dp, huh? So yeah, so therefore we have h is equal to the square of 34 times sine theta plus 59.0 degrees. Okay, so yeah, this is a pretty simple part. Part 3, state the maximum value of h and find the corresponding value of theta. Alright, this should be quite easy, right? So the maximum value of h, so of course that will be when this is equal to 1. So this is just square root of 34 meters, right? Okay, so but what value of this will it be? So we will have, this will be when this is equal to 90 degrees, right? So theta will be equal to 90 degrees minus 59.0 degrees, and this is equal to 41.0 degrees. Simple enough? For the last part, we need to find the value of theta when h is equal to the square root of 17. Okay? So h is equal to square root of 17. But square root 34 is square root 17 times square root 2, which means that we know that sine of theta plus 59.0 degrees is equal to 1 over the square root of 2. And guess what? We know of, this is a special identity, we know of the two angles that will satisfy this, which are 45 degrees and 135 degrees. So that means that theta is equal to 45 degrees minus 59.0 degrees, or theta is equal to 135 degrees minus 59.0 degrees. So theta will be equal to negative 14.0 degrees, which is rejected, of course, because we are looking in the range of 0 to 90 degrees, or theta will be equal to 76.0 degrees. And of course, this is the value of theta that we accept. Okay? And that's it. That has been the O-Level AMATS 2011 Paper 1. I hope that you have found this walkthrough useful. Once again, if you have any questions about the walkthrough, please leave them in the comments below. Alright? Thank you.